Hello, everybody. Good morning and welcome to our webinar today. We greatly appreciate your attendance. This is a comprehensive guide, top to bottom, of the ANSI ISEA Z358.1-2014 standard for emergency equipment, eyewashes and safety showers, our forte at Haas. And we're going to jump right into it. So, beginning, very first thing, the presentation is just for educational purposes. It's not meant to be distributed widely, rather to be used for educational purposes. We will, however, share a PDF of the presentation afterwards for your reference and to help continue your journey towards understanding the standard better and towards enacting testing and things like that. So with that said, just a quick note that any questions that you have during the webinar, anything that comes to mind, post those questions in the question section in the control panel, and we'll get to those as quickly as we can. I'm going to make some quick introductions here in a couple slides, but my buddy Hayden is in the background and he'll be answering some of those questions in the chat. Otherwise, we'll be sure to follow up with answers to each of those questions in an email post-webinar. So we also have the Q&A section at the end of the webinar, so I'll be trying to get to as many of those on the webinar as I possibly can. Okay, so watch for that follow-up email after the webinar, but we'll try to get to as many as we can coming up. On to the bribe. So like I said, we'll be sending you that follow-up email 24 to 48 hours. You can expect that to return. It's just going to take me a little bit of time to make sure that I get all of the questions compiled, answer all of those, put it in a nice Excel spreadsheet. You'll see each of the questions and answers so you can review those and you have all of those available to you directly. We're going to launch poll questions throughout the webinar. There's only a handful of them, but they're really important to us to get your feedback and keep a thumb on the pulse of how it is that you're, if you're enjoying the presentation, how we can improve the presentation, and make sure that we are making adjustments to this presentation appropriately. And the last part here, a follow-up survey, is going to be sent out after the webinar, and I'll buy you coffee. We'll give you a $5 Starbucks gift card for your participation in that survey. So coffee on us if you don't mind participating. On to the introductions. My name is Justin Dunn. I'm a product specialist and trainer for Haas. I've been with the company for about 7 years, and my biggest focus is educating others on ANSI, ADA standards, our product, and things of that sort. So with me is Hayden Delgado. He's my partner in crime in the marketing area. Hayden, do you want to say hello real quick?
Hi, everyone. I'm Hayden Delgado. I'm the field marketing specialist with Haas, and I've been with Haas for about 4 years now. I just want to remind everyone, if you have any questions that you would like to address, please put them in the chat. We typically get quite a few questions. I can't promise all will be answered live, but we'll get to as many as we can and send out answers to any that we don't later on.
That's perfect. And yeah, and any that Hayden can't answer, I'll be sure to take care of either at the end or in that follow-up. And then with us also in the background is Nicole Dennison. She's our marketing manager and kind of helping to run things in the background. On to our topics today. Of course, what is the ANSI ISEA Z358.1 standard? What are the significant requirements of that standard, and what do you need to focus on to accomplish testing inside of your facilities? So I'll break those down and simplify that process for you. Best practices for emergency equipment, an FAQ that Hayden's going to cover, and then I'll do the Q&A at the end. Okay, so everybody knows, likely if you're attending a safety webinar, certainly one focused on the ANSI standard, you know who OSHA is. They are the Occupational Safety and Health Administration. And they are responsible for the regulation of emergency shower and eyewash facilities. Their standard is 29 CFR 1910.151C. Can be found under the medical services and first aid, and they give us just this paragraph, this explanation, really just letting us know that where you may be exposed to corrosive materials, that you need suitable facilities for quick drenching. But this is all that they give us, which is why the ANSI standard is so important. And they use the ANSI standard as the primary source for compliance with 29 CFR 1910.151C, because they don't give us the how, where, when, etc. kind of questions that come up frequently. How do we accomplish this? How do we stay compliant? Now, onto the importance of compliance. The overall goal, obviously, is preventing injuries and fatalities, lowering general workplace risk, lowering lost time and money, and that potential for both the employee and the employer, right? So there's an agreement there. There's a trust that's built there, right? If you're going to come to work here, we are going to provide all of the safety protocols and equipment and put everything in place to protect you from what you're going to be potentially exposed to on site here, right? So we can get people home to their families safe and avoid any permanent damage or changes to their lives outside of work. Now, OSHA has stepped up enforcement, particularly for employers who have a history of serious or repeated violations. Those are two of the most serious violations that OSHA hands out. On August 1st, 2016, OSHA fines increased for the first time since 1990, and it was by a gigantic margin because it had never been adjusted for inflation before. And that increase was by 80%. So they were basically catching up. They were filling in a gap where they failed to adjust that amount. And going forward, effective January 2nd, 2018, OSHA fines will increase by an additional 2% to account for inflation as they see fit, probably year over year. This is a big scary map. This is just an example of some of those fines across the U.S. This is all public information. You can find this out there. There's obviously a couple elephants in the room here on the slide. Bigger fines, bigger penalties, and you know, it could be something as simple as, you know, this athletic club. They probably had a pool. Employees are working with pH chemicals. They didn't have an Eyewash or a shower station to protect those employees. And either something happened, OSHA showed up, or they showed up and found something and they repeatedly failed to improve the safety situation on site, and which is what results in such a large fine. Now, onto what the standard is. So it was written by the International Safety Equipment Association, and that's what they do. They write standards for all sorts of things, this one being a safety standard, and it defines the shower and Eyewash design, location, temperature requirements for proper functionality and usage, all of the things that 1910.151C fails to do for us, which is why OSHA again references the ANSI standard as that primary source for compliance. Look at this to comply with this, right? Now, it was first published in 1981. It's had multiple revisions afterwards, 1990, 98, 2004, 2009, and most recently 2014 is the current version of the standard. There's no grandfather clause, so whatever, so compliance is always with the most current revision of the standard. Otherwise, a grandfather clause would have been included, explaining that if you had emergency equipment already installed and this was the standard at that time, then you don't have to upgrade, but it's always up to code with the most recent version, right now 2014. 2009 and 2014 included some really important revisions that we like to remind people of. In 2009, temperature range for water delivery, simultaneous use, which was really important, and Eyewash testing requirements. In 2014, this was more geared a lot of the changes heavily geared more towards the manufacturer, but also other changes. So design, manufacture, and installation of emergency showers, equipment installation location, and some adjusted measurements to some of the other requirements inside of the standard. Now, with that said, and before we get into the significant requirements and how to test, Hayden is going to launch poll question number 1. And again, we really greatly appreciate you participating.
Thank you, Justin. This is poll question number 1. The question here is, which best describes your role in choosing showers and eye face washes? The options for this are place the order, install and or maintain the product, specify product and plans, decide or make recommendations, or I do not have a role. We'll give everybody a few seconds to answer each of the poll questions, and we appreciate all the responses we receive and the help that that provides us with. Looks like we have a good amount of responses coming in quickly. I appreciate that. I'll give everybody a few more seconds before I go ahead and close up the poll. All right, thank you everyone. I'm going to go ahead and close it up.
I always love seeing how many people participate in that. It really shows me that you're here to participate and not just have it on in the background. So that's much appreciated. So on to the significant requirements and how to test your equipment for those significant requirements. So to begin, one of the most important things that we need to talk about, and one of the most frequent things that we get questions about, is weekly and annual testing. Okay. The testing requirement is weekly for emergency equipment. There's lots of ways to accomplish that, whether you have, you know, people specifically in an area that are responsible for just their emergency equipment. You have somebody whose primary job is checking that emergency equipment, or if you have hired someone similar to our Haas services team and things like that to perform those weekly testing requirements for you. And similar with the annual inspection, which is much more in depth. So let me explain the differences. So weekly testing is very straightforward. It's very simple. It doesn't take a lot of time. Best practices is to look for more things that might be wrong with the emergency equipment, but the most basic requirements are: 1, that it happen on a weekly basis; 2, that activation ensures flow of water to the heads of the device. All right, it has to activate. We need flow from the shower if there is one, and in the eye wash or eye face wash if there is one. The duration of the activation, and this is most important, and the reason why this is a weekly basis, because when it was on a monthly basis, we were realizing there were issues that we needed to solve, so it was upgraded. And the purpose of it is to clear out all of the stagnant water that collects in that piping, in what's referred to as the dead leg portion of the piping. So ultimately, the goal is that an emergency piece of equipment it gets installed in the corner, you maintain it, it's there when you need it, and it has to work correctly. Realistically, as long as safety protocols are being followed, PPE is being used, etc., we're hoping, and you should be hoping, that that's the last thing that you need to use is resort to first aid on site. So that equipment rarely gets activated for any real reason. And realistically, that water is just sitting and rotting inside of the pipes, and you're going to have to deal with things like Legionella and other bacteria and buildup that can get inside of the pipes if not flushed out properly on a regular basis. And that's all that's required on a weekly basis. If the unit is self-contained, tank not plumbed, then all that's required is that you look inside the tank or verify that there is enough water inside of the tank to provide a full 15 minutes. And that's just following the manufacturer's requirements for that piece of equipment so that it'll function for a full 15 minutes. The annual inspection is a full head-to-toe test of the emergency equipment, and I'm about to cover all of those things, so I'm not going to go into depth on this at this moment, but realize that as I move through this presentation, all of the things that I'm talking about are the things that you have to cover. We'll also include our testing checklist in follow-up materials as an incredibly handy guide to utilize in your facilities and for the annual inspections. So we'll be sure to include that. Everybody loves a freebie. So tools, some of the things that you are going to need are number one, a tape measure, Eyewash gauge, which is directly taken from the ANSI standard. They gave us how to design it, what its function was, and we created our own model 9015, like most manufacturers. It's just a little plastic gauge. 5-gallon buckets with 2-gallon water lines marked, the shower sock and pole, a thermometer, and the ANSI checklist, just to make sure that you're covering everything that you need to cover during the testing process. On the right here, this is our 9011 test kit, and comes with each of those things that you're going to need for a test. So remember, on a weekly basis, you have to activate. A lot of the times this isn't being done because it can be a very messy process, right? You turn on that shower, it's spraying water everywhere, which is why you want to focus on using something like the 5-gallon bucket, the shower sock, but it's also to capture that water so we can measure it and test the temperature of the water and other things. But I'll explain those coming up. Now, to really start on the requirements. Number one, the equipment needs to be accessible within 10 seconds or 55 feet. 55 feet was a measurement given to us in the appendix of the standard, because 10 seconds was wildly different for everybody, right? I can move 10 seconds faster or slower than many of you that are on this call. And they didn't define whether it was, walking and running and stuff like that, and you're going to be impaired, likely your sight, especially if it's a chemical spray hazard. So 55 feet is a good measurable distance that they added to give us some more guidance. So, and for that test, you're just checking proximity to the hazard. Get a tape measure, check the distance, and you're good to go. The second is that it needs to be located on the same level as the hazard. So between the area of concern where potential exposure might happen, ensure that between there and the emergency equipment, there are no stairs, changes in floor, and things of that sort. And that goes for the next requirement too, that it be free of obstructions, and you check both of those the same way. Just ensure that there is nothing obstructing the path of travel between the hazard and the emergency equipment. This is really important because of what I explained earlier. It goes in the corner, hopefully you're maintaining it, but oftentimes people, it's kind of an afterthought, and stuff collects around it, just like you see here in the photo. It builds up around it and it becomes an obstacle for somebody that's seeking first aid, and we really need to try to avoid that. Next, it has to be identifiable with highly visible signage. This one's easy, but if the unit's outside, you're going to want to check regularly for deterioration of the signage. Ours are treated to avoid it being damaged by the sun and stuff outside, but that's not the case for all signage, especially if you sent out for custom signage, or I've seen the craziest signs. I mean, straight down to like a piece of paper with some Sharpie that said, hey, this is a shower. And we want to try to avoid that. Hopefully it's waterproof, hopefully it's sunproof, and it's highly visible so it can be identified immediately and easily, since again, your vision is probably impaired. Deliver flushing fluid for a full 15 minutes. So to test that, you need to run the piece of equipment for a full 15 minutes. And that's just on an annual basis, once a year. It's got to run for a full 15 minutes, and that's to ensure that it is capable of doing so. I know that can create a mess. Hopefully the unit's outside. If it's inside, try to direct the water towards a nearby drain. If that's not possible, there are larger tanks and things like that that can be found to capture the water, and other devices to funnel it again, to an area or outside. The outlets need to be protected from airborne contaminants. This is just dust covers. We have to make sure that the heads of the device are covered and any stored flushing fluid is covered to avoid any contaminants from getting into the head and blocking it, or into the tank and potentially clogging it from the inside, or creating a nasty environment that stuff can grow in. Ideally, if it's self-contained, you're using something like our bacteriostatic preservative or cleansing stick, so that that water is preserved over a length of time, and to avoid that type of contamination. But all of the outlets have to be covered, except if they're facing down, like a shower. That wouldn't make any sense. There's no use for a dust cover on a shower. The nozzle is facing down, nothing's going to collect in there. Dust covers also need to be self-removing. So this is during activation. So when you activate the equipment, just make sure the dust cover pops off or removes itself without any additional steps having been taken to remove it. Very important. The unit has to go off to on in 1 second or less, and it has to remain on without the use of the operator's hands. Okay, many people think that this section of the standard, it sticks in your head, and lots of people hold on to it. I get calls about it all the time, but they think it's one motion, that one movement and the equipment has to turn on, and that's not the case due to a few different types of equipment that are required in certain situations. So it's actually in under 1 second the equipment has to turn on. Just like you see here, my buddy McDean down in production is activating that 8300, 8309. So, and this is done through activating the equipment. You just need to make sure that flow to the heads of the device is under 1 second or less from activation. And it's obviously needs to be hands-free. You're gonna have other things to deal with, right? You're gonna have to remove your clothing. You gotta be in your birthday suit, which is most ideal, especially with chemicals, right? You're gonna continue to get exposed, especially if it's being trapped between your clothing and your skin. You need to spread your eyes open. You need to, handle a lot of different things during this emergency. We don't want you to have to hold the shower open and hold the Eyewash or face wash open. And it used to be fairly common to have self-closing valves in place. If you have a self-closing valve, that has to be replaced. There's no place for that in emergency equipment nowadays. It's too taxing on your time while you're in that emergency equipment to have to hold those open, and we want to make sure that's avoided. Now, eye washes, face washes, and drench showers all have their minimum requirements for flow rate. Eye washes are a 0.4 gallons per minute, 1.5 liters for my friends up north. The 0.4 gallons is just because there's the two streams of water. It's treating each of your eyes, and that's it. An face wash, which is much more common and realistically the industry standard nowadays, is having an face wash. So that's more likely what you're going to run into nowadays. 3 gallons per minute for an face wash, and that's because it's treating both your eyes, but also the areas surrounding your eyes, your forehead, your cheeks. Again, pretty unlikely that a chemical would just get in your eyes. It's probably going to be a skin irritant, possibly too. So we want to make sure that your full face and eyes are all being flushed at the same time. Drench showers require a flow rate bare minimum 20 gallons per minute, which is already a lot of water. And if you can imagine having corrosive, damaging chemicals on your body, and 20 gallons per minute is a lot of water, and it's very quickly. We like to think we do a very good job at Haas of dispersing that water evenly and making it a more tolerable situation, considering victim comfort and things like that during probably one of the most horrible days of your life. But if you're dumping 30 and 40 gallons per minute down on top of somebody, it's going to hurt real bad. Which is why flow controls and things like that are so important. And these are all bare minimums for that supply. Hopefully they consider adding a maximum limit for GPM someday, but I don't think that's going to happen soon, but that would be a nice change. Now, what they did add was a requirement that that flow be at a controlled flow for the flushing fluid and at a velocity that's low enough to be non-injurious to the user, okay? As you can see here, there's a controlled amount of water coming out of the shower head. It's evenly dispersed, and the eye face wash is, the user can tolerate it. Your face can sit in there for a full 15 minutes without it being damaging to your eyes. Now I'm going to show you what that looks like. So just test this by confirming and ensuring that the flow rate from the shower eye face wash and the patterns are being met, and I'll show you how to do that. So here are a couple examples of what too much flow and too little flow looks like. So on the left, we got a brain washer. This is the type of unit it's going to be too painful to use. There's no way that you could sit there for 15 minutes, let alone a couple seconds, and put your face into that unit, especially with that spraying into the soft tissues of your eyeballs. It's going to be incredibly painful and probably do more harm than good. On the right, you choose which eyeball you want to save. We don't have enough water here. Flow controls aren't being used. Each of these heads actually requires about 8 gallons per minute each. And there's just not enough water to sustain the functionality of this equipment. So too much water, too little water, both very dangerous situations, and why testing is so important, so we can discover these issues and act on these so that the equipment works when it needs to. Now, the way that we test this is, I referenced the 90-15 gauge a little bit earlier on. Again, this drawing was given to us by ANSI. They are at the ISEA, really. They showed us how to make this. They gave us the drawing, and it's based on average human anthropometrics. So average human eye spacing, and ensures that we can use this tool to discover whether the equipment is usable or not. So the flushing fluid has to cover the areas between the interior and exterior of a gauge at some point less than 8 inches above the nozzle. And I'll show you how that's done. Get a little video here. So you can see that we're measuring up to 8 inches and then slowly lowering the gauge to ensure that the Eyewash gauge is being met. And I'll give you a top-down view here. So remember the minimum flow rates. If the gauge is not being met, you can see the water is hitting the eye circles on the gauge. We know this is usable. This is going to meet your eyes correctly, and is entirely usable. And this is also how we test those flow rates from the Eyewash or the eye face wash. With how they're designed, if there is not enough water to meet those minimums, the gauge test will fail. And we're just ensuring that it's usable. But that is how you test for that requirement. Now, the flow pattern is required to be 33 to 53 inches above the surface floor of the user, no lower and no greater. And that's to ensure that that's within an area that's reasonable for us to use, right? If it's too low, it's going to be difficult for us to maintain that position. If it's too high, many of us aren't going to be able to use it. So certainly the shorter amongst us. So it needs to be within that range. It also helps to minimize the potential for the flow pattern to be injurious, like what I showed you earlier, an extreme amount of water coming out of it. If it exceeds that height, it's automatically non-compliant, and we need to put flow controls in place, retrofit it, and take steps to improve that flow. Now, the standard used to state 45 inches max, but it was to the head of the device. The head of the device couldn't be over 45 inches, and that didn't do anybody any good. That wasn't a very helpful portion of the standard, and it's more important that we rein in the flow rate and the top of that flow rate in the standard. So that's what's required there. The minimum distance around the eye or eye face wash heads has to be, and it says from the wall is 6 inches, but really it's any obstruction around it, right? And the point is that it doesn't obstruct the flow. and there's nothing that you're going to have to contend with for space or hit your head on anything when going to use the equipment. So ensure there's a clear space of 6 inches around the heads of the device. Piece of cake. Now the flow pattern, again, 33 to 53 inches from the floor. Just use a tape measure to determine the height of the flow pattern, measuring from the floor that you're standing on in front of the unit. Minimum distance, again, 6 inches. Just use a tape measure. Check around, make sure there's no obstructions, and you'll fall into compliance there. The shower, remember that the minimum flow rate for the shower is 20 gallons per minute. You're either going to have, most commonly, it's rare to find a shower by itself these days. A shower alone is really just meant for PPE decontamination. Because realistically, if you get sprayed, the likelihood that it's not going to affect your face and your eyeballs is real low. So a combination unit is ideal for chemical situations. So when you have a combination, remember that your minimum flow rates are increased to 20.4 for a shower and eyewash, which is much less likely these days. Eyewashes aren't ideal for a combination unit, and that's because it's not covering your face. If you have a shower in place, the idea is full body decontamination, and it just doesn't make sense to just rinse your eyeballs out. So a shower and eye face wash is really industry standard nowadays, and the minimum amount of water for that is 23 gallons per minute, typically between 30 to 90 psi. Certainly for our equipment, that's the requirement. Now, to test the shower flow rate, you're going to need that 5-gallon bucket. You're going to need the shower sock, unless you want to take a soggy walk through your facility to go change. They call them drenched showers for a reason, and the thermometer. Okay. Now, the test is very simple for this. Place the thermometer in the bucket. It's going to take that temperature while it fills up. Place the shower sock around the shower head and hold on. So sometimes those, 30 gallons per minute and above can really grab that shower sock. You want to make sure that you're holding it in place right. Even the guy in the photo was like, I'm gonna hold it way up here. And then activate the eye wash or the eye face wash while the shower is running. Activate it before. We want that eye wash or eye face wash running during that test. Because we're also testing for simultaneous use issues. Oftentimes the shower will starve the eye wash or eye face wash, and now you have to make a choice between saving your skin or saving your eyes, and that's a dangerous situation, and one that's not frequently discovered because people don't test the showers. If they don't have a shower sock and something to control the water, it's impossible to get in and out of there without getting wet. So activate that eye wash. Activate the shower for 6 seconds and count it off. Do your 1 Mississippi's all the way through 6. Check that the 2-gallon water level mark is met on the bucket, and you will know that you are meeting your 20-gallon minimum for the shower. Okay, it's just like checking a pulse, right? The nurse doesn't sit there for a full minute and count your pulse. She counts it for 10 seconds or whatever and does the math in their head. Okay, so if you're meeting that 2-gallon water line over that 6 seconds, you're meeting 2 gallons in your or 20 gallons in 1 minute. Now the shower flow pattern is also very important to test, and if it's a quick activation, it's easier to get away with. This is easier to do outside. You're gonna have a little bit of cleaning up to do inside on that annual test, but the shower flow pattern, the column of water has to be 20 inches wide at 60 inches above the surface floor. The reason for this is, again, average human measurements. It's meeting you shoulder to shoulder and covering your entire body. The center of that column of water also has to be clear by 16 inches from the center of the column in any direction, to ensure that there's plenty of space for you to stand within that column of water. So you can see on the left, this is compliant, nice wide spray pattern. And then on the right, there's not quite enough water here. Sometimes it's just the equipment and the way it directs water down onto you. oftentimes showers that you see that use a shower bell are a big issue because it's dispersing water, hitting the bell and shooting it down. And what a lot of people don't realize, I call it personally the donut effect, but there's no water in the middle of the column from that shower. And that can also be a dangerous situation, but it's not mentioned in the standard. Just keep an eye out for that type of activation because it's not rinsing your body correctly. But on the right, this is what we want to avoid. This isn't wide enough. It's not covering you shoulder to shoulder. Here's a good test. So this is how you do it. Grab the tape measure, open it, ensure that you're getting 20 inches wide, measure 60 inches up above the ground. So long as that's being met, the shower flow pattern is compliant. The shower head has to be 82 to 96 inches above the floor, anywhere in that range, and that's for the outlet of the water. And that's making sure that if it's too high, if it's above 96 inches, the shower flow pattern might be too wide and not rinse your body correctly. If it's too low, it's going to be too narrow. So same issue, it's just going to be more focused and not cover you entirely. So make sure 82 to 96 inches. The pull rod activation for the shower needs to be no higher than 69 inches from the surface floor. And again, that's to make sure that the shorter amongst us can reach it. If it's placed too high, activation can be difficult. And if your vision is impaired, finding it, while jumping up and trying to grab it is going to be pretty difficult. So there's also nothing in the standard that says it has to be a pull rod. That's industry standard to have a pull rod. But some equipment is installed on the outer wall of your facility, and it can be a push paddle too for the shower, but it has to follow these requirements for height. Combination units, components need to be positioned so they can be used simultaneously and operated simultaneously by the same user. This is what I was talking about earlier with that starvation. This is one of the most dangerous situations that is very frequently not discovered because people aren't testing showers. And what happens is the water takes the path of least resistance through the equipment, everything dumps out through the shower head, and if there's no flow controls in place, and we learned our lesson way back in the day, we started including flow controls in all Haas equipment standard for ages now. The shower head will starve the equipment. It'll take up all of that GPM, and it won't push anything back down to support the Eyewash or iFacewash. And when you activate it, there won't be anything coming out of it. So this can be corrected through retrofits and other measures, but we want to make sure that you are discovering this because it's very dangerous. So Eyewash, iFacewash, shower has to work at the same time, but they also have to be, again, positioned so that the shower head is directly over the Eyewash or iFacewash. Some people get the instructions, throw them away, and they think the shower is for one thing, the Eyewash is for another thing, but they are designed to be used for one person at the same time. So make sure they're correctly aligned. You'd be amazed how often we find that. It's doing site surveys and things like that. It's all over the place. Shutoff valves obviously need to be installed for maintenance purposes. Obviously really important for being able to shut the equipment off, do any maintenance that's required, or anything that needs to be fixed on the emergency equipment. But that shutoff valve creates a situation that's rather dangerous and something else that we find. So the requirement is that those shutoff valves be locked open. Provisions need to be made to prevent unauthorized shutoff. That's typically in the form of a locking ball valve that's installed or a lotto device like you see in the photo. Something that's a lockout tagout that maintenance can be in charge of. Remove, shut it off, do your maintenance, turn it back on, and be held accountable for replacing that lotto device. So if you have a real healthy lotto policy and procedures in place, then that shouldn't be really an issue. But trace the supply line back, find that shutoff valve, make sure it's locked open. It's got to deliver tepid flushing fluid. That's super simple, 60 degrees to 100 degrees Fahrenheit. It's very important. And what it does, ensuring that the water is in that range, is ensuring that the user is going to be able to maintain that 15 minutes of use. They're going to be able to withstand all 15 minutes. If it's way too cold or way too hot, they might exit the equipment too soon. And we can't have that. If they exit too soon, you know, first responders are probably going to ask, how long were they in the shower? Did they completely get the contaminants off? If they exit, they're going to continue to be damaged by those contaminants. And we need to try to avoid that. It's also just horrible. I mean, my shower on average is like 104 degrees in the morning, and 60 degrees on the low end is still, it'd be hard to sit in for 15 minutes. And if it's too hot, it's going to react negatively with chemicals. So testing that, just run the water. If it's an eye wash or eye face wash, place the temperature gauge like directly in the flow of the eye wash or the eye face wash. If it's a shower and you're testing it, just throw the gauge in the bottom of the bucket and you'll have your answer in a couple minutes. Employees who might be exposed need to be instructed on the location and proper use of emergency showers. We do this for all of our staff at Haas. They need to know where the emergency equipment is, but specifically too, that for their areas, that they know exactly where their equipment is, exactly how to operate it, and they know that they need to be in there for a certain amount of time. So that kind of training is incredibly important. We suggest quizzing employees on a regular basis. Where's your nearest piece of equipment? How do you activate it? Check the need for freeze protection. That's pretty straightforward. You'll need a piece of equipment like you see here on the right. That's most commonly what you're going to run into if you see freeze protected equipment. It's the 8315 CTFP, and it's a combination freeze protected piece of equipment, and it's heat traced. So there's a heat trace cable throughout the unit inside of it, and the shell is protecting that piping from freezing. So it's very likely what you have in place if you're protecting against this. Check for freezing patterns, temperatures throughout the year, but if you have a particular time during the year where freezing's likely, double check. If the pipes freeze, obviously nothing's going to come out, but it can also do a lot of serious damage to your emergency equipment and cost you more down the road. Now there are two appendices to the ANSI standard, Section A and Section B. I just really quickly wanted to touch on what each of those things cover. Appendix A are safety considerations, and so A1 is just eye wash units, personal wash units, I should say, can be kept nearby to supply immediate flushing fluid, but are intended as supplemental devices only, not primary equipment. If you have those squeeze bottles, which is what a personal wash is, or supplemental bottle, those are just meant for immediate treatment, not a full 15 minutes, and you need to have primary equipment nearby. A2 just notes that a physician or other appropriate safety professional should provide guidance on specific hazards and emergency eye wash shower equipment. A3, consider consulting local authorities, local, state, and federal on the proper disposal of the waste water flushing fluids. So if there's something particularly hazardous, consider contacting local authorities and see about proper disposal of that. You probably already know since you have it on site, and letting it just go down the drain might be dangerous. And then A4 just drives home the importance of personal protective equipment, and that having emergency equipment in place doesn't excuse you from maintaining proper prevention devices like safety glasses and things like that, right? We want that front line of protection, PPE, in place, personal protective equipment in place to do our best to prevent more serious exposure or exposure at all if it can happen, but this first aid equipment needs to be in place and working properly in case it does. B is, there are 7 sections. The first, B1, just ensure you have properly sized piping supplying your equipment. 1.25 inch piping is the bare minimum that we suggest at Haas and that we require for our equipment, and that's pretty much standard throughout most safety equipment providers. B2 states that it's the responsibility of the owner to ensure the equipment is installed and supplied in accordance with the manufacturer's specifications. That one's pretty straightforward. B3 under the valve operation really just covers, it has a kind of a rare rule in that schools, specifically education centers that have emergency equipment, can have self-closing valves so long as it's approved by whoever's in charge of safety for those facilities, right? And that's all. And that's because you know, kids can be turds, and if they activate the equipment and leave it on, etc., without any kind of supervision, it can do some serious damage to the schools and you know, do some serious damage to the school budget. So self-closing valves are an exception for schools, but only for schools. B4, just consider the use of alarms. They're particularly useful in remote areas, and the faster first responders can arrive, the more likely survival is and avoidance of permanent damage. B5, we'll cover B5 in the next few slides, so don't worry about that. I have a couple examples. B6, temperature guidance and the importance of tempering. We'll also cover this in an upcoming slide. And then B7 covers the intent of the weekly activation and its goal being to flush the supply lines and reduce the chance for harmful bacteria to grow. It just drives that home, that's all. So section B that I just mentioned, section B5, covers installation considerations. Okay, and there are two things. I have two slides here, but the first one is that a single step up into an enclosure is compliant, but it has to be an enclosed booth type of unit. And the reason for that is we can't make these flush with the ground, especially a tempered booth like you see on the screen here. This is the E-Pod. Over on the right are tempering equipment for extreme environments, and it can't be made to be flush with the ground. It has to be a sealed compartment. They understand that, and so a single step into the booth is allowed. But that's it, no other changes in level, certainly not for normal plumbed equipment that's not in a booth. Doors, very important. You can have a single door in place, but it has to meet certain criteria to be considered not an obstruction. So number one, it has to be non-locking. The doors have to open in the direction of the emergency equipment. The hazard has to be non-corrosive, and they have to be push bar or panic bar operated. And there you go. That's it for the appendices, and which is going to bring us to poll question number 2. Hayden, if you would launch that, please.
Our poll question number 2 today is, what are you likely to do after today's webinar? Check all that apply. Do not answer if the question does not apply to you. I also want to state that we didn't mention this at the beginning of the webinar, but we are giving away an Axion kit for free to a few of our lucky winners today. In order to qualify, you had to register and join us for the ANSI webinar, and we'll be doing the drawing soon after the webinar concludes.
I can't believe I forgot that. I love giving stuff away.
Same here. We got a good amount of responses coming in quickly again. I love to see that. Give everyone a few more seconds before I close it. All right, thank you, everyone.
Excellent, moving on. This will be a short section, but it's just a couple of reminders of some best practices. Number one, make sure there's adequate space for emergency responders around the equipment, right? They don't want to be contending for space while they're trying to help this person. Locate other first aid equipment near the emergency shower or Eyewash. If you have first aid kits, defibrillators, etc., it's a great place. Make a safety area, safety station, somewhere where all of that can be located, so you're not going on a hunt for equipment that they also might need. Train employees how to access and activate the equipment during in emergency. Very important. Next, this one's actually a different ANSI standard. It's Z358.1. It has to do with color coding for hazards. And this is more of a bragging point for me. I love bringing this up. But red is danger stop, emergency stop bar button. Yellow is tripping, falling, and striking hazards. Orange is parts of machinery that can cut or crush, etc. Green, like the color of a specific safety manufacturer whose webinar you are, I think, attending right now, is the location of safety equipment. And we keep driving this home, and some manufacturers have started to kind of catch up with that color coding, but green is the location of safety equipment. So we have, throughout our history, used green to ensure that people are quickly identifying green emergency equipment, safety, etc. Blue is just for policies that aren't safety related, and then the other colors, like purple, gray, black, are for definable by the user. Quick reminder of the correct equipment for the hazard. Eyewash, it's just wood shavings, dust, airborne particulates. Eye face washes, like you see here, are for more minor incidents affecting only the eyes and face. Drench showers are for PPE decontamination. And lastly, combination units, most popular type of unit, and certainly the type that covers the most or is ideal for any type of situation is the combo unit. So chemical exposure to the eyes, face, and body, just to drive it home, which is for which. We very frequently see people misuse certain types of equipment, like an Eyewash only for like a forklift charging station, where the hazard is corrosive battery acid. So a combination, for instance, would be more appropriate. Tepid water, remember 60 to 100 degrees. Otherwise, they might be driven out too early. If it's too cold, we risk hypothermia, cold shock, cardiac arrest, and things like that. If it's too hot, again, your average residential shower is like 105 degrees Fahrenheit. Legionella bacteria thrives between 95 and 115. So unfortunately, it kind of overlaps the ANSI tepid water range. Ideally, you want to aim for 85. Which is most ideal. And you run the risk of hyperthermia, getting too hot too quick. Just quickly touching on this, so this is some follow-up information for you. There'll be some information on this in the follow-up email, but we wanted to introduce everybody to the new Haas integrated ePod series. These things are incredible. We've already been providing this equipment for a really long time. We overhauled the line recently and made some drastic and incredible improvements to this type of equipment. They're highly rugged, unequaled in build quality. They're powder coated now for corrosion resistance and long life. There's no material in this that can decay quickly. All metal construction with high density insulated walls. So they're very tough, very rugged, and the great kind, the type of equipment that you would want to make like a safety station, you know, provide a first aid kit, etc. nearby. They're perfect for extreme weather conditions, indoor or outdoor solutions, just depending on what it is that you need. The tempering equipment can be housed inside of the equipment, so you just have to provide water and power. They're perfect for all applications. There's a combination unit inside, so ideal first aid response, and it gives somebody a private area to experience an emergency. It also has our high vis doors. Those doors aren't like painted green. Those are actually LED lit doors. And we found that during an emergency, especially if you have chemicals in your eyes, that is going to be as highly visible as possible, and you'll be able to find it very quickly. And poll question number 3, Hayden, if you would.
Our third poll question is, would you be interested in learning more about the Haas integrated ePod that Justin just covered in the past 2 slides? All right, thank you, everyone.
Perfect. So moving on from there, a couple quick additional best practices: remove contacts. Obviously, they can get trapped, the contaminants. Disrobe completely, including socks and shoes. Provide privacy curtains. It's a horrible day in your life, and a little bit of modesty and privacy would be ideal. Bump test before high-risk tasks. Be cautious while assisting not to contaminate yourself. Ensure correct type of signage. So if you have an Eyewash sign where there's a combination unit, that just doesn't make sense. Make sure it's the correct type. And then be cautious of the proximity to electrical nearby. So next, we're going to talk about the survey program that we provide here at Haas. And what this is a complimentary emergency shower and eye face wash survey program. I run this myself here at Haas. As you can see here on the right, these are our direct results from surveys that we have done based on over 1,000 emergency equipment, pieces of emergency equipment. That giant Pac-Man size is 78% non-compliant pieces of equipment found that were performance-related issues, which is so awful, and it's kind of the ugly truth behind emergency equipment. Only 12%.
Hey, Justin,
yeah.
I don't mean to interrupt, but it looks like the slides have not progressed since the last poll question.
Oh, that's interesting. How about now?
No, still looks like it's there.
Oh, okay. Well, I saw the poll question pop up there for a second. Is it closed?
It's closed. We're taking a look at it from our end. Just give us 1 second, please.
Okay, well, I'll just keep explaining. So let me make sure I'm sharing the, I'm sharing the screen. Everything looks good from my end. So I'll keep explaining while they try to figure it out, but it includes 1 full day of inspections, an inspection report, an executive summary chart, recommendations on how to fix everything that we find inside of your facility, debriefing meeting and web conference. And the only restrictions that really apply are that you're within a certain distance from a trained representative of ours, all trained by yours truly. We have somebody in every state throughout the US and also in throughout Canada. So really important program, and highly useful for you to interact with us and for us to help you bring you and your facility into compliance. So please reach out to us if you're interested in a survey. I'm going to progress to the next slide, which is a poll question, and we'll see if launching that poll question kind of helps to correct what's going on with the slides.
Yeah, it looks like we're able to progress now. So our 4th and second to last poll question is, would you be interested in a free site survey of your existing emergency equipment for ANSI compliance? Sorry to everyone about the technical difficulties we had there, but it looks like we're back on track now.
Who goes to a webinar and doesn't secretly hope something goes wrong? You know what I mean?
All right, thank you everyone for the response. I'm going to go ahead and close it up.
Thank you very much. And then if you could confirm to me, Hayden, that the slide, you can see it?
Yes, I can.
Okay, and then over to you for Haas Services.
So Haas Services is a service that we provide that's going to really differentiate us from the rest of the market. And that is because we are the only manufacturer that provides a warranty and field service like this for emergency showers and Eyewash products. We often find that the issues that we see are not knowing how to test for the ANSI standard, and that can lead to fines for non-compliance or even injury of an employee, which nobody wants to see. The program is set up to help you achieve ANSI compliance in any environment, while also removing any potential pain points that you may have at your facility. And we're going to provide this service to you regardless of what brand you currently have installed at your facility. You can see at the bottom of the slide a few of the quick things that Haas Services provides. That is, insurance of your equipment will be tested weekly and annually, preventative maintenance and contract, repairs and upgrades, startup and commissioning, and our online competent person training and certification that we offer, as well as a warranty service. Haas Services is it's a great way to help us ensure that we're complementing those superior products that we provide you with, while also providing you with the best possible service we can all year round. And then our fifth poll question, and our final one after this, we'll get into some FAQs as well as our Q&A. And our fifth poll question is, would you be interested in learning more about how Haas Services can help you achieve ANSI compliance? Thank you everyone for the participation today. We've had great participation in the poll questions, and as I said earlier, that helps us a ton.
And for sticking around, we greatly appreciate it. I know this is running a little bit over, so we understand if you got a bolt, there will be follow-up information, and we'll send the Q&A questions. But we are going to cover the FAQ and then some contact information for us here at Haas. And we'll follow up just immediately with all the answered questions and answers in an Excel spreadsheet form.
We'll go ahead and close up our final poll question.
I always end up getting too passionate, and I run a little bit long, so sorry everybody. Go ahead, Aiden.
So for our FAQs, the first one that we have is, does ANSI apply in Canada? Yes, the standard is referenced as the primary source of information on emergency equipment in every territory and province in Canada. The only exception to this is BC. They have their own version, but it still uses ANSI as a basis, and it's just not enforced as strictly as it is here in the US. What is required in weekly tests versus annual tests? Weekly test is going to be just a simple activation of the shower and the Eyewash, just long enough to clear the dead leg that could be in the piping. And the annual test is a comprehensive test encompassing everything that we've covered here today. Does a door constitute an obstruction? I saw this question coming quite a bit today, actually. The answer to this is yes, but as long as it meets the guidelines stated earlier, then you may have one door in place. As Justin said, it cannot be locked. It must open in the direction of the equipment. It needs to be push bar operated, and the hazard must be non-corrosive as well. Are requirements for drains included in the standard? This one's a little tricky. They're not, but there is a section in the appendix that states that consideration should be given to local requirements for proper disposal of the contaminants that may enter the drains during that decontamination process. So you should look at local plumbing code to determine drains and locations for them as well.
Perfect, thank you, Hayden. And then with the questions and answers section, I love it. We hardly had a dip in attendees, so we greatly appreciate you sticking around. I'm gonna really dive into these right after the webinar. We'll lay out all the questions. I'll put all the answers on Excel spreadsheet, share those all with you via a follow-up email, but I feel bad about taking more of your time. So, because I know you got important things to do. So what we're gonna do is focus on that Excel spreadsheet. We'll take care of that for you, get it back to you as quickly as we can. And with that, in closing, Hayden and I just want to show our appreciation for your attendance today, your continued support, and for taking this information and going forth and sharing it, hopefully. Improving your compliance, focusing on providing an environment that's safe and improve that trust with your employees or with your employer, and provide a safe environment for your team. So please reach out to us if you have questions on ANSI, emergency equipment, whatever it is that you need. My contact information is right there. We also have a live chat function on our website, www.haasco.com, and our customer service team is top notch. They're absolutely incredible and would be happy to help. So please enjoy the rest of your day. Thank you so much for attending. We'll be back with an ADA webinar soon, and we'll run another ANSI webinar later on in the year. So thank you, everybody. Greatly appreciate it, and have a great day.
Thank you, everyone. And we will be reaching out to the winners of our Axion kits here shortly.